Hello everyone, welcome to the final lecture for week 11. So we have been discussing about modeling long context in the last few lectures, and this lecture will talk about retrieval augmented generation, popularly known as RAG. We already gave you some ideas in this course about RAG, but this lecture will be completely focused on this. So what we will cover today, so first of all, why is there need for retrieval in LLMs? So we will talk about some motivation that why RAG is actually needed. We will talk about some particular models that use retrieval while doing the next token prediction or doing the generation. We will revisit the KNN language model that we talked about in the last lecture in this particular context, that how does this KNN LM connect to the RAG formalism, and we will spend some time on the training details, how is it trained. And so first of all, let's talk about the motivation, right? Why do we need retrieval? So what you are seeing here on the slide are different frameworks for doing question answering. So your task is question answering, right? So how would you do this question answering task? Now in this course itself, we have talked about in many ways, like remember this question answering applications we talk about. So you have a particular query. Now you may want to retrieve information from a large data set, like some external knowledge, Wikipedia and so on. So you may have a retriever. This can be as simple as BM25. You can use dense vectors. Now, given this ranked context, you know the more important passages for this query. Use them in another model, like reader model, that will find out what is the start and end span and to get the answer, right? So this is a retriever reader framework. You are not generating the answer, but once you get this rank context, you can also generate an answer, right? So you can give these context to a model. Like here it may be like a BERT model that can say select spans, but you can use a GPD model, right, that can generate answer. So you can even do a generator, generate answer. This is like retriever generator, and that's very close to what we will call as RAG. Or you can say, okay, why do I need a rank context? Why can't I simply ask a question to the model like GPT and get an answer? Like this is a simple generator. Now, why is this particular view even possible? Because these models have been pre-trained on such a large data. So there is an idea that they have some parametric knowledge. That means through this large training, they have encoded some information in their parameters itself, that given this question, they would be able to use that knowledge and actually answer. Right. So we talked about this zero shot answer generation from GPT-2 that has already been trained on so much data. Given a question, it may be able to retrieve that knowledge and get the answer. Right. It can use that to do tasks for which that particular knowledge is required, because they are nearly trained for every data that is available on the web. So, but the question is then why do we need retrieval? Right? Why do we need to augment them with retrieval? So that's the term retrieval augmented generation. Why do we need that? So there are certain issues with the language models like that, and that's why retrieval is preferred. For example, this is at a certain screenshot of this model reported in paper in 2023. So what happens? So suppose you ask certain question to the models, and they will give a very nice format, like list 5 important papers authored by Geoffrey Hinton, and it gives a very nice answer. The renowned computer scientist. Here are 5 important papers authored by him, and it gives actually 5 references, and it turns out the first 2 are really the works by Hinton, and this is correct. But then it starts giving you output that are not by Hinton, like deep learning book. So it may have put Hinton as, it may have many references from Hinton's paper, but this is not authored by Hinton, or it's not a paper, right? Paper by Hinton. Hinton is not even an author for this, and then it also lists attention is all you need paper. So while Hinton is not an author for this, right? So these are things that are not correct. And what this paper found out, for example, like in GPT-3 Da Vinci 03. So they say, okay, let's query this for different entities as per their popularity. Like some entities are very popular, means they will be occurring in a lot of instances in the pre-training data, while some may not be so popular, they will occur in very few instances. So what they found, if you this is model without retrieval and this is through retrieval. So if you query for popular entities, the unassisted language model itself gives a very good answer, right. So this has a better accuracy than a RAG model. On the other hand, if you look at the tail entities, that means they don't have so much occurrence. So clearly unassisted language model performs worse than retrieval augmented, right. So retrieval augmented can help in the case of entities that are not so popular in the data, right. So LLMs can't memorize everything like that they have been trained on in their parameters. So they may focus more on the more frequent entities, which it seems to be giving a better accuracy than the RAG model. So so hallucination is one particular issue, especially for tail entities, that they may not have complete memory, but they know the format. So they may actually end up hallucinating. Now this slide gives you some idea about what is hallucination in a brief taxonomy that is presented in this paper. So typically what is a hallucination? So you are getting a response that is not faithful to the facts of the world, right. So nicely, you can have it as a question answer. It's a binary question answer. Is it verifiable? So whatever response, is it verifiable based on the knowledge of the web? So answer may be no. See, if it is not verifiable, you can just call it, you cannot factually verify it. Of course, there may be nuances, like because many times they may invent entity and talk about it. So then you can't even verify this. It may be a subjective statement, unverifiable. So let's not even talk about this part. But suppose if it can be verified from the web of knowledge, then you can ask again questions like, okay, so does it contradict with the evidence? If it doesn't, right, so it may be just entailment, just putting it another way. So then it becomes a factual statement. So that's the only thing that is factual. But if it does contradict, right, then you can go deeper, like is it contradicting the entity level, the entity name itself is wrong, or certain relationship is wrong, or at the sentence level it is wrong. So you can have various kind of categories among these. So yeah, so hallucination is one problem because of which RAG is preferred, because RAG avoids this hallucination problem to a certain degree, right. Because even after RAG you still do generation, so you may have hallucination, but at least you have some context to refer to. Similarly, another very important problem why RAG is preferred is that, so all these models typically are pre-trained up to a certain point, right. So like this is another snapshot where the question is who is the CEO of Twitter, and the answer is given as per the knowledge cutoff, right. So of certain time CEO is Jack Dorsey, while if you query Google you will get the current CEO from 2023, right. So now that means, see, LLM has already learned this knowledge that who is the CEO of Twitter from the web, but that is up to a certain time point. Now you can say I can edit this knowledge, you can do model editing and all, but that's an area of research. You don't have very good methods that can do exactly that update and do not disturb the other models. Now on the other hand, if you use retrieval, you can keep on adding the details to your database, you can keep on updating your data store. That's much more cheaper than training your model from scratch, right. So training model from scratch will be too costly, but your data set can be updated, right, and you can expand it. So that means you can simply have a way in which you can access, given a query, a large database, retrieve information from there, use that to answer your query. That would be much more suitable. So that's another reason why RAG is preferred, because the LLM memory, knowledge is already can easily be outdated, right. It is trained up to a certain point of time only. Then again, when LLM gives output, it's difficult to verify it directly. So it may help if it gives an output along with some citations or references from what sources it has got the output. So that's where again RAG can help, because you can trace the knowledge sources from retrieval lists. That I got retrieval lists from these websites. So while writing the answer, I can refer, right? I can easily refer like this, or 1 and 2. I can refer the source, I can cite the sources from which I got the answer. So, this has become this has been one of the main interesting use case of RAG model, that you can give citations, right. Like here you want to create an itinerary for exploring Toronto over a span of 2 days. You get an answer from Bing, but I mean what would help, what actually helps here is that you have various footnotes. So, you are linking to various websites from which you are collecting information and providing to the user, right. So, this becomes much more interpretable, that yeah, I got this information from this website, you want to know more about it, you can go and see this, right, and gives much more trust in the output of the language models. So, then what is retrieval augmented generation or RAG? So, we have a input to a language model, right. So, we have a particular task that the language model wants to do. Now, along with that, we want to give it some extra information, right, and for that we can give a query, we can do a query to a large data store, which can be like trillions of tokens, right, billions of trillions of tokens. So, we can query that, and this will be like simple text documents. They may not be labeled at all, just pages or passages put together, not structured data set or knowledge bases. They can be normal documents. So, I can query and get some relevant information and use that to aid the language model, right. Now, so you see the input and query we have put as two different things, because the input to the LM may be different, but what you want to query the index can be decided based on the task, right. What really do you want to query the index? It need not be the same as the input to the language model, and we will see some scenarios why this is needed. And based on this query, you want to find a small subset of elements from this huge data store that are most similar to the query, right, and you will append that to the language model along with the input and want to get the answer. Now, how do you really do retrieval? So, once you have this query, how do you retrieve from this data store? Now, these methods we already discussed while talking about question answering. So, open retrieval, right, question answering. So, what is our goal? You want to find a small subset of elements in a data store that are the most relevant to a query. So, fine, you have a query and you have set of documents that are stored. You can find similarity based on various methods, like you can do an unsupervised method, you can use TF, IDF, BM25 kind of retrievers to get a similarity score between two pieces of text, and then once you have similarity, you can rank them. So, this is one particular idea. You can use TF, IDF, or you can use something that uses the encoder. So, you can put query and documents both as encoder, and based on the similarity of these encoders, you can give the similarity of a particular text passage or chunk with the query, right. So, you may have query and document encoder, and we talked about Colbert and other kind of architectures. So, what is our goal finally? So, I want to find a small subset of elements, right. So, our task is given a query that is given for the retrieval part. I want to get top k documents from the entire data store based on the similarity, right, similarity of query and document. How do we find similarity? We talked about two methods, but you can also do it by other things, like you can do fast nearest neighbor search. If they are in the embedding space, you can use some methods by which you can just search through that embedding space. So, like there are various popular methods. So, FAISS and distributed FAISS scan, there are some very popular methods that you can try and explore. These can be used for finding similarity, right, and we will see at the end. There are also some recent methods like OpenAI embeddings. You can use OpenAI embeddings, Contriver, and so on for also doing this retrieval. Now, so retrieval is one part, but then the question is really what do you want to retrieve? So, do you want to retrieve the passages? So, let us say you have taken all the documents in data store and put them in passages. Would you want to retrieve the passages, or would you want to retrieve the tokens, or would you want to retrieve something else, right? That is the question. And where would you want to use the retrieval? So, one thing is you have the input, you want to append the context in the input itself and let the model generate, or you can append even the intermediate layers or at the output layer, right. I mean, you can append at various places. Of course, the most default way is appending here. You have the input, append the data here and let the model do the generation, right. And then the next thing is, when do you want to retrieve? So you are generating, you are doing a generation task, it may be a long text generation task. So when should I retrieve? Should I retrieve only at the input and that's all, or while generating should I retrieve at various points? So this is like you retrieve only, so you retrieve only once at the input and that's all, and you continue with the generation, or after every token that you generate you do the retrieval, right. So you can retrieve every token and you continue your generation, or you can do a retrieval, do some generation, after some time you again do a retrieval. This can be adaptive, I mean when do you retrieve and when you do not retrieve, right. So you can, so there are again a lot of different interesting design choices here. Okay, we will talk about some of these, we may not cover everything that we are talking here, but I mean this particular tutorial that will be also reference for this lecture gives this in I mean lot of details. Okay. So let us talk about one particular method like realm. So this was based on the BERT architecture itself. So idea was that suppose you are doing this task, World Cup 2022 was, and I mean some sentence, the increase 2, and this is a mask token, I mean you want to complete this and everything else is there. So how do you complete this? So they say okay fine. So you have the sentence in the query, the input to the LM, you encode it, right, using the hidden states. Similarly, you encode your entire data store has the passages encoded. So in this case they had 13 million chunks from Wikipedia, and then you encode each of this chunk. So they have also some embedding. Now, so you I mean through encoder you have the embedding for all of these, you have the encoding for these. You can do some similarity matching to find some top k from this. So you retrieve some k chunks, right, that are most similar, I mean most similar to the current input. Now based on that, what you can do, you can put this chunk with a separator to x and then let it do the prediction for the particular mask word. It will do the prediction, what is the probability of getting a word, right, given chunk g1, g2 and gk, because you can put them in independently there with x and get a distribution. And so once you have this distribution, then you also know what is the probability of g given x, right, because of the similarity. You can see the final output will be, I will take okay only this is the top k chunks that I have selected. For each chunk, what is the probability of the chunk given this input, and given this input and the chunk, what is the probability of this output, and you sum over all the chunks. So that is one way you can define your distribution. That was a realm paper. So later on there were other papers like this in context retrieval augmented language models and replug, right. So what they said was, I mean let's put it to a language model. So this was a BERT, previous one was a BERT model, but let's put it to a decoder language model. So here this is your current input, World Cup 2022 was the last with 32 teams before the increase 2, right, I mean, and you want to complete it. So what you do, okay, you have this query, let's say you give this query to the retrieval and you get this output. You can get multiple blocks also, but in this case just to take the point, so we get one output. So you will put this output before the input, right, and you may put some separators in between, then you again have this, and then you pass it to the language model. And a language model will use only this ID, I mean only this input, this particular retrieved context or set of blocks along with the current input, and try to complete 248 in the 2026 tournament, right. So this is the retrieval in context language model. And what they found, so they say they use simple BM25 for the retrieval. So they computed perplexity and across various sizes of the language model. So what they found, across all sizes, if you do retrieval, it always helps. So this is the perplexity without retrieval, this is with retrieval, and you know the lower is better for perplexity. So this actually helps. So retrieval also helps the language modeling, right, in general. Now then the question that we talked about, I mean what should be the query to the retrieval? Should it be the same as the input to the language model? So think about generation when you are generating data, right. So this is your input. So team USA celebrates after and so on, so, and then World Cup 2022 was the last with 32 teams before the increase 2. So this is your entire context. Now should I give the entire query to the index? So what they found, suppose I give the entire query to the context. Now, because it has the entire context, it may do similarity with everything, and it turns out it retrieves like US national team defeated Iran 1-0, right, based on similarity, right. It may be more similar to the first part than the last part, but it does not cover the token that we want to generate next. On the other hand, if you use just this part to retrieve, it gives me the correct chunk that helps me generate the token, right. So, this is more relevant. So, that means it is not necessary that my query should be same as the input. And what they found in the paper, that is using a shorter prefix or which has more recent tokens, right. What is more important, that use the more recent tokens for retrieval as a query, this helps, but should not be too short. So, they plotted like, okay, if you go from 64 to 32, your perplexity is improving, right. 32 is better than 64, but if you go too short, it again goes up. So, that means you need to have a sweet spot where you use the previous context, but not too long. Yes. So, just the more recent tokens, but not too long a context is what they found. Then coming to the problem, like how frequently should we do the retrieval, right. So, they again tried this. So, said let us say this is what we am generating, World Cup 2022 was the last with, right. At this point I do the retrieval, and this is what I retrieve, the 2022 World Cup, 32 national teams involved in the tournament. This is what I had till now. I pass it to the LM with this retrieval and the current input, and I get 32 teams. But this is good, I wanted to generate this, but I also wanted to generate before the increase to 48, but I do not have it right now in my retrieval, right. So, at this point when I retrieve, I may get some information that can help me do the immediate completion, but may not be able to help me for long term completion, right. So, better is that, okay, I do some completion based on this, but I do another retrieval, right. So, that means, so let us say I generate 32 teams before the increase, right, but then I do another retrieval with this, and that will help me another chunk that can help me completing this part before the increase to 48 in the 2026 tournament, right. So, if I get a retrieval result from a new query, that can explain this new token. So, that means you may not want to do retrieval, I mean at one go alone, but you may want to do retrieval at many points on time. And what they found in this paper is that actually if you do retrieval more frequently, it always helps. So, perplexity is always improving if you go from retrieval stride 64 to 32 to 1. 1 means every token you are retrieving, and that is the best, right. But it also comes with a cost, because retrieval has a cost. So, if you retrieve at every step, you will also have a cost associated at the inference time, right. So, there is always a trade off. If you are, so if you just focus on the performance, I mean performance in terms of the perplexity, you will find that retrieving more frequently helps. But if you are more interested about some trade off, you may want to take some sweet spot where you retrieve more often, but not at the token level. Now, in this context, let us revisit the KNN language model that we talked in the last lecture, right. So, what are we doing there? Remember we said that we will have some representation of ZI WI in the data store, and given the current HI, I want to find which ZI are the closest, and whichever ZIs are closest, I will take corresponding WIs, right, as my memories that I want to attend to. So, what are these? So, let us say what is our current scenario. So, we want to do some text completion, say Obama's birthplace age is my current context, I want to complete it, right. So, what is my target? So, I can get the representation of whatever I have text till now. So, this is my current representation HI, right. At the same point of time, I can say in the data at every context, I will have a context and the next target, right. So, Obama was senator for is my context, and target is Illinois, that means the next word. So, I want to say which is the context that is similar to the current context, right, that is the idea. So, if a context is similar to this, I can easily use the token that comes after to replace here, right. So, idea is that I take this context, I do a representation, and given this particular query, I try to find which of these representation is the closest, right, and whichever are closest, I use the corresponding tokens to assist me in generation, right. So, So, which tokens in a data store are close to the next token, right, which is equivalent to which prefixes in a data store are closer to the prefix that we have, right, and equivalent to which vectors in the database are close to the vector we have, right. That is how this problem is formulated. So, what you will do, so you have these vectors in the database also at your current representation. Now, you find the distance or similarity. So, let us say these are your distances for all the representation and the current representation, and you find some top k from here. So, this is lower the better. You normalize them, so something like e to the power minus t I distance, and convert into the probability distribution. So, you get 3 tokens in Hawaii, Illinois, and again Hawaii, right. So, aggregate them. So, you get them like 0.8 and 0.2 for Hawaii and Illinois, right. That is the distribution that you are getting. At the same time, from your language model, you can use this representation and get the generation output, and then you interpolate. So, lambda weight is given to the KNN and 1 minus lambda to the LM, right, and you get the final distribution of tokens and use that to generate or sample from this, right. And this lambda is a hyperparameter which actually can be tuned depending on various things. We will see one of this aspect. So, that is KNN language model for you in the context of retrieval augmented generation. So, what they found that KNN language model actually outperforms, this is the no retrieval. So, you have the same language model Wiki 100N without using any retrieval, and as soon as you start using KNN with some database, right. So, as you increase the database, its performance is improving for KNN LM, right, more database, more better performance. Interestingly, even if you use a 30 times more powerful model, Wiki 3 billion, without retrieval, KNN LM is able to outperform that, right, with some size of the data set, right. So, interestingly, with bigger data store, it was able to perform better, even better than a larger model. Okay. And yeah, I mean, of course, if you increase the number of neighbors that you are selecting, this also helps in the perplexity. And very interestingly, see what happens if you use it in out of domain text completion. So, you have trained this model on some data, but you try it on another data. So, what they say, okay, in another data, if you want to do, your language model is trained on one data set. So, your lambda, that is for KNN probability, and 1 minus lambda is for the LM probability. So, for out of domain, you can give more weightage to the lambda, right, because you can use the data store from out of domain, right. I mean, you have a data store, but your language model is not trained on that domain. So, language model is trained on domain 1, but data store can be from anywhere. So, this is domain 2, and you are actually doing the task for domain 2, right. So, that means your weight lambda should be high. You focus more on the data store than on the language model. So, that is what they found for this out of domain adaptation. They put lambda close to say 0.65 or so. So, that means put more focus on KNN, while if they are doing in domain, they will put lambda to be something like 0.25, where if more focusing on the current language model, but you are also getting some idea from the retriever. So, yeah, I mean, finally about training, how do you train this retrieval based language models? So, I mean, the challenges there are that this external database that you have is huge, and it is very difficult to update the index, very expensive also, because you have to recompute all the dense vectors for all the documents, right. At the same time, the LLMs are also large. So, it is also expensive to fine tune an LLM to generate answer. So, yeah, when you have to train it, many times you just use unsupervised methods. So, for retrieval like BM25 and so on. But if you want to use some fine tuned models, so there are options like you can do independent training. So, you train retrieval models separately, you train language models separately, and just put them together, right. That is one option. You can do sequential training. So, the idea will be that you first freeze your retrieval, just use the language model. So, one component will be first trained independently, and then you fix that, freeze that, and other component is trained with an objective that depends on the first one, right. So, what you will do, you will train the retriever, so that they will provide the text that helps the language model the most, right. So, you can train them sequentially. So, that is another aspect. You freeze one model and train another, then you freeze this model and train another, right. So, that is what you can do in sequential training. You can also do joint training, but when you train both this index and your language model, you don't want to update it at the same rate as you are updating the language model. So, you will have asynchronous index updates, right. So allow the index to be stale for some point of time, and then you rebuild after certain steps, right. So, you do not rebuild it every step. So, that is one thing that you will have to keep in mind. Okay, backpropagate with asynchronous update, right, is important for a large data store. You can also do joint training with in batch approximation, that rather than taking the entire index for a batch, I can just take a subset of the index based on certain positive and negative examples, like we talked about in the case of dense passage retrieval. So, this would be much smaller than the full index, right, and then you can update both encoder and the in batch index. So, whatever in the in batch, you will update that part as per the training, but yeah, not the full index at a given point of time. So, that is another idea. Now, yeah, there are various papers that talk about these models, and they also mention some pros and cons, like if you do independent training, sequential training, easy to implement, but and easy to improve, but they are not end to end trained. So, they will not give you the best possible performance. But if you do any of this, you will get very good performance, but again, it complicates the training a lot because of the efficiency issues. So, you will have to take care of some batching methods and overhead, and still there may be some train test discrepancy when you do this. So now, I mean, we talked about long context modeling, we talked about RAG. So, which is preferable? Should we go for RAG? Should we go for long context? So, I mean, this is not a very easy answer. So, this is from one of the paper, right. So, what they showed that this is ICLR 2024. So, they showed that okay, they used a model along with retrieval and for certain tasks, and they show the average, and they found that across models using retrieval generally helped. Yes, so using retrieval was better than the long context directly. So, that was what they had found, but improvement was not too much. I mean, you will see they were very close, the numbers are very close. This is a more recent paper. So, where what they found is that it is completely opposite. They said okay, you try long context versus RAG, and they have used some like very most popular models like Gemini, GPT-4 and GPT 3.5 Turbo, and they find that long context is always better than the RAG. So, that means you use long context than RAG. But I mean, is it that you can always use just long context and RAG is not so important? So, they talked about another trade off. They said okay, so in general if you talk about performance as per the numbers, in their experiment long context was much better than RAG. Okay. So, long context was better than RAG for cross models, and more so in the recent model like GPT-4. But if you look at the cost for RAG is much less than what you have for the long context, right. So, there is a trade off about the cost and the performance, and they used a very simple strategy. They proposed a very simple strategy called self route, right. So, what is the idea? They said okay, because RAG takes much less time than the long context model, but it gives a low performance. So, what we can do? So, this is a simple strategy like RAG and route. So, they will actually do a RAG every time. So, they will have a query, they do a RAG, but like what we do in RAG, we take the results and directly get the answer. They do not go directly to that step. They first ask the model if the question is answerable based on this retrieved context. So, they have this question, they have this so you say you can write unanswerable if the query cannot be answered based on the provided text. So, this is an additional thing that they provide to the language model, and the language model has this option to say no, it is answerable from this context. So, then if it says so, right, if it says so, they will go back to the long context. Okay, so, this is a simple routing mechanism based on the LLM answer. So, for the queries that are seen answerable, you simply use RAG as the final answer, or the queries that are unanswerable, we proceed to the next step, that is we provide the full context to the language model and get the long context prediction. So, this was the self routing, but overall I mean the takeaway is that okay, there are RAG, there is long context, they have pros and cons, and it seems there can be way in which you can combine them together also for doing the task. Okay, and this particular ACL tutorial that I also cited in slides would be a very good reference for knowing more about rec. So, this also ends our week 11, and we will then move to week 12, where we will talk about interpretability and ethical considerations. Thank you.